Now, typically the maxima and minima, the calculus problems are combined with other concepts. Like for example, in this case, we would solve a problem which combines the maxima and minima with the concept of arithmetic progression. So that is how the problems are asked, and that is where the students have trouble. Even though they might know the concept of arithmetic progression very well, they might be able to solve problems. They might know the concept of calculus, the maxima and minima, how to do differentiation very well. But as soon as we combine these two concepts, the students will become confused. Of course, subscribe to this channel because we will be focusing specifically on such problems where we have to use the combination of concept. So from our arithmetic progression, we know that the seventh term of the AP would be A1 plus n minus 1, which is 7 minus 1 into D. Now this has been given to us as 2. So what does this mean? Can I find the value of A1? So yes, of course I can find the value of A1. This will come out to be 2 minus 6D. Okay, so now I know the value of A1. What else do I have to find? I have to find the sixth term. So sixth term I can find as A6 as A1 plus this is 7 minus 1. So the sixth term would actually be equal to 6 minus 1, n minus 1 into D. Okay, that is one way of finding out the sixth term. So value of A1 I can substitute from here. That is the one way. Another way is to actually realize that my sixth term will actually be equal to my seventh term minus D. So if I go one common difference back, that is where I'll land up on the sixth term. So this is actually equal to 2 minus D. Now what have been asked? I have been asked a function y such that it's a product of sixth and first terms. So sixth term and first term, so that is 2 minus D multiplied by 2 minus 60. And I've been asked to actually minimize this function, right? That is what it's saying. It is saying that I have to find the value of D such that this multiplication 2 minus D, 2 minus 60, that is the minimum. The value of y becomes minimum. So very, very simple. I can simply look at this. I can say this will come out to be, I'll simplify this. This is a quadratic equation, 6D square. And of course, then we will have this minus D multiplied. So this will be 2 and this will be multiplied also 12. So this will come out to minus 14D. And then the last term will be 4. Okay, so that is what it comes out to be. Now you can graph this. You should actually, as soon as you see this formula, we will try to minimize it. But before we minimize it, we have to understand whether it will have a minima at all or not. I mean, it's not that we are wasting our time. So for that, we will just graph it a little bit. We know from our parabolas and hyperbolas that yes, of course, this will have a minima, definitely. Its shape will be something like this. So we already know that, okay, but if we don't know a function, before doing blind differentiation, by finding the maxima and minima blindly, we need to get a feeling for how that function looks, okay, and we have done several such problems on DoorstepTutor. We have graphed the functions for you, okay, so definitely go there, understand what does this graphing mean. We are trying to get a feel for the function, whether we are not doing something which is completely nonsensical, okay. This, just by applying the mathematical derivative, we might just do things completely nonsensical. So in this case, of course, as soon as we find the derivative, we will trying to find the minima. Okay, this will equal to 12D minus 14, and this, of course, this is equal to 0. I equate this derivative to 0, and this, of course, implies that my D will be equal to 14 by 12, and that is nothing but 7 by 6. Okay, so that is where the minima would happen, a D equal to 7 by 6. You can substitute this value back here, okay, and then our A1 will come out to be 2 minus 6 into 7 by 6. This comes out to be 6 and 6 would cancel. 2 minus 7, this comes out to be minus 5. Okay, so very, very simple. That would be our first term. Okay, so that is what the question actually asks. It asks the first term. It does not ask for common difference. So that's another thing we have to realize, that we have to give the answer in terms of what is being asked. We just cannot do whatever we wish. Okay. So now with that, let us just graph this function a little bit. So we have done the graphing here for you, and this is what this is the minima. This function has a single minima, and that is what we have been able to find. Okay, so with this, try to solve many such problems yourself and try to understand how functions are going, how to find the maxima and minima, and things will hopefully become much easier for you. Okay, so this minima is what we have tried to find here, this is the minimum value of this function. Okay, this is 6d squared. Okay, so this is 6d squared, and then this is the minima we have found, and this is where it happens. Okay, this value is actually equal to 7/6. That is the value we have found. So try to graph some functions, try to find the minima and maxima only after you have, in rough, you have just graphed the function a little bit. That will help you understand the concepts a little bit better. Thank you.